Alright, hello guys, I'm Ron, and I'm here to teach you a little bit about the first unit of Algebra 2 Trig, which is on the Regents. And this deals with operations. So we're going to start with radicals. And a radical is a square root of something. So, for example, we can begin with saying that rad 4 equals 2, rad 9 equals 3, right? These are all perfect squares. We could also say that the square root of any number squared is that same number. Alright? But you always have to remember that it's plus or minus that number. So, we could say that the square root of 3 squared equals plus or minus 3. Alright? Back here, this is not exactly 2, it's plus or minus 2. This is plus or minus 3. Alright? That's the most important part of taking the square root. That's something I always do, and I always mess up, and that's what most people mess up with square roots, because it's not that difficult, but if you forget this, you do get the wrong answer. A couple vocab tips: you could say that the number outside of this radical, for example here, right? So if you have a cubed root of, let's go with 27, alright? This 3, this is called the index. This 27 is called the radicand. Now, this is not very important to remember. You could go through all your math career and not know this, but you know what? It's helpful, because if a stupid question comes up and they're like, oh, what is the radicand of this problem? You'll know what it is. Now, there's properties of radicals that are very important. The first one is the one I put up here, right? The square root of n squared is plus or minus n. Then the second one will be would be, say, square root of AB will give you the square root of A times the square root of B. Alright? And the final property of a radical is the square root of A over B equals the square root of A over square root of B. Now these work also if you had a cubed root in here. If you had a cubed root in here, each one of these would be cubed root. If you had a cubed root in here, each one of these would be cubed root, and so on. So, in order to simplify radicals, they're very easy. So, you say you have rad. Let me see. Let's go with rad 12. Right? You could break this up into rad 4 and rad 3. Okay, so the insides have to equal the radicand based on this rule right here. Alright? And now, what you want to make sure you're doing when you're simplifying a radical is that one side is a perfect square. Alright, so you know that rad 4 equals 2, so then rad 12 equals 2 rad 3. Alright? And that's the basics of simplifying radicals. Now, we can go on with many examples of this and many applications of this, but as long as you know that you know how to multiply radicals, how you know how to divide radicals, you'll be set. So, if you want to do just one example of radicals, we can say that you could do 3 rad 2 times 5 rad 3. And what does this equal? Well, when you're doing this, you have to know that you're multiplying the coefficients by each other. So we get 15 rad, and then you're multiplying the radicands by each other, and you get rad 6. Okay, so that's very basic. So you have to distribute. Let's say that's example 1. This is example 2. If you had rad 5, and you had rad 6, and no plus. Let's go with 2. How would you simplify this? Well, or distribute this? You would get rad 30 plus 2. Rad 5. This can be never mind. So that would be your answer. Alright, so you just use the distributive property. You can only add or subtract radicals if they had the same radicand. So an example of that would be rad 2 plus rad 2 equals 2 rad 2, right? So, but you cannot simplify rad 5 plus rad 2. Okay, this cannot be simplified over here. They can only be simplified and added together if they have the same radicand. Right, so if you have rad 5 minus rad 2 rad 5 minus rad 5, then you'll get rad 5. So that's subtraction. Dividing radicals is just going to use this property. So if you have rad 5 over rad 2, the only way you can simplify this any further is if you made it rad 5 over 2 inside. Alright, so that's radicals. Very simple. And remember this concept, plus or minus. That's what I always get tripped up on. And that's something very, very important. Because if you do not put plus or minus, you do have the wrong answer, according to Mr. Myers.